In this video, I am going to talk about a root finding method known as bisection method. This method is based upon a theorem known as Bolzano's theorem, which is corollary of intermediate value theorem. So according to Bolzano's theorem, let a function is continuous in a closed interval AB, and also let that f at x equal to a and f at x equal to b are of opposite signs. Then there exists at least one value of x, let us say that value is alpha, such that functional value at alpha is equal to 0, and so alpha is root of the function. If I need to understand it graphically, then let me plot function with respect to x, and at some point x equal to a, the function value is positive, and at some value b, the function value is negative. That is, f at a is positive and f at b is negative. Then this curve cuts x-axis at some point. That point, let us say, is r, and this r is root of the function, because at this value the function value is equal to 0. Function could also be like this, where between two extremes x equal to a and x equal to b, it cuts at multiple positions on the x-axis. In this particular plot, this curve is intersecting x-axis at 3 points. So it means that f at r1, f at r2 and function value at r3 are equal to 0, and r1, r2 and r3 are the roots of this function. However, at a time, using bisection method, we can obtain only one root. Also, we can obtain only real roots from this method. How this method operates? So let us say that x naught is the initial approximation, and the initial approximation is chosen in between point A and point B, that is a plus b by 2 at the middle of this, or mean value of this. So the steps in the bisection method are that, let us say, if the product of f at a and f at xr is negative, where xr are approximation where r is 0, 1, 2, 3, and so x0, x1, x2, x3, like that are the approximations. So it means that in this case f at xr is negative. If I plot it, I see that xr is somewhere here. It means that the value of function at xr is negative. Hence the root lies between a and xr, and so the next approximation will be a plus xr by 2. On the other hand, if let the product of f at a and f at xr is greater than 0, that is f at xr is positive, the situation is like this. Here the functional value is positive. So it means the root lies between xr and b, and so the next approximation will be xr plus b by 2. This way we will continue until a condition will achieve when the product of f at a and f at xr, the nth approximation, is equal to 0, where xrn is the nth approximation and nth approximation, and this is root of the function because at this value of x the function is 0. So then we will terminate the operations. Now if I look at the interval b and a, so this is b, this is a, so the interval b minus a is this. Now if I take the first approximation, then we have halved it. So if I proceed to nth approximation, then this interval will become b minus a by 2 to the power n. If I take that b minus a by 2 to the power n is less than or equal to some tolerance or accuracy, then in this case if I take the logarithmic of this, then I can write down it as log b minus a by tolerance log 2. So if I have predetermined accuracy in my mind, then I can find number of iterations after which the operations need to be terminated. So I can find out it beforehand that after how many iterations I need to terminate the operations. For example, as an example, if b minus a is equal to 1 and I have predetermined accuracy in my mind, that is 0.001, So if I put these values in this equation, I find n is greater than or equal to 10. So it means at least 10 operations are required to achieve accuracy of 0.001. Now, to understand this with an example, that how this method works, let me consider that the equation is x cube plus 9x minus 5. So the function, let me consider, is x cube plus 9x minus 5. And first of all, in this method I need to find out the interval. So if at x is equal to 0, the value of function is negative, and at x equal to 1, the value is positive. So it means root lies between 0 and 1. I have plotted this equation and I find out that a real root exists at this point, and I have to find out this real root. So how these operations go in case of bisection method? As we have found out that the interval within which the root lies is 0 and 1. So the first approximation will be 0 plus 1 by 2, that is 0.5. Next, at x equal to 0.5, if I calculate the function value, it comes out to be minus 0.375, that is negative. Hence, the root lies between 0.5 and 1, because at x equal to 1, the function value is positive. Hence, the next approximation to the root will be 0.5 plus 1 by 2, that is 0.75, and then we will check the function value at 0.75, and depending upon whether it is positive or negative, we will continue the operations accordingly. I have tabulated all these in a table. So as we can see that at x equal to 0 and x equal to 1, the function values are negative and positive respectively. So the approximation is half of this, that is 0.5. Now at 0.5, the function value is negative, and at 1, the function value is positive. So root lies between these two, so that is 0.75. Now at 0.75, the function value is positive, and at 0.5 it is negative, so root lies between these two, and so half of this is 0.625. Now, how we can calculate error in successive operations or approximations? So let us say xr prime is the later approximation, xr is the previous approximation, and xr prime is the later approximation. So this is error. This is how we can calculate the error. And so in this case, for example, here in the first approximation, the error will be 0.333333. In percentage, if I want to find out, then simply I need to multiply this with 100 and I get in percentage. So the error will be 33.33%. In case of first approximation, it is 20% in the case of second operation, and so on and so forth. So here I see that the the error is about 0.1%. And so if I have predetermined accuracy of 0.1%, then the root will be 0.539 correct to 3 decimal places. Now there are certain problems with this method. One of the problem is that this kind of function, the function is 2x to the power 4 plus x square. Now here we don't see that at two extremes the function values are of opposite signs. So therefore in this method, that is bisection method, cannot be used for such situations. Cannot be used for finding root. Other problems are that using bisection method, complex roots cannot be obtained, and because each time we need to halve the interval, so therefore this method is a slow method. Also we see that always the approximations are between A and B. So therefore this method is also called bracketed method, and it is one of the bracketed methods. Other bracketed methods also exist. So because of the problems, like it is a slow method, we can use other root finding methods which are faster.